ठीक। ठीक। जी। ठीक। Good morning, ladies and gentlemen. Welcome to the joint chemistry conference in 11 Maret University 2024. Let me introduce myself. I'm Triana Kusumaningsih. I am the moderator in this room. In this room, there are 7 presenters. Each presenter presentation for 10 minutes and discussion for 5 minutes. Okay, let's start the event. First presenter is Ms. Henry Giandari from 11 Maret University. Okay, please, the time is yours.
Thank you, Mrs. Tiang, for the time. Good morning, everyone. My name is Hamza Adinia. I'm replacing Professor Henry of Medicine. I'm a student from 11 Maret University, and I would like to present my presentation entitled Synthesis of Zinc Oxide and CDDs by hydrothermal method as photocatalyst material for mycobacterium pesticide degradation. Next. Introduction. Mycobacterium is our research object that the specification shown in this table, and we have to notice the important thing about mycobacterium. They are the type of danger. It has toxic to aquatic life with long-term effects, eye irritation, toxic to reproduction, and dangerous if swallowed. And it has a high toxicological threshold. So we can conclude that mycobacterium has harmful properties. Next. This is the pesticide contamination in our aquatic life or environment, especially aquatic environment. So the pesticide residues can flow through drainage or spread to the air into the air and then fall drainage. And so the surface water possible to contaminate with the pesticide. It also absorbed by the soil and then contaminate groundwater. And it's important to find a solution for pesticide degradation. And there are many of methods that we use to for water degradation, like adsorption method, filtration membrane, method, and ozone. But this methods produce secondary product or other phases that require further processing. So these methods are not environmental friendly. So we use photocatalyst as a method for pollutant degradation, especially for mycobacterium, because photocatalyst reaction with organic compounds, pollutants, produce environmental friendly, namely water and carbon dioxide, and it has cheap manufacturing cost, so it makes this method relatively more effective. Next. So photocatalyst is the technology that uses materials as catalyst, and then it accelerates the chemical reaction with the help of light. And also among this, the interesting materials are zinc oxide and also NCDs. Zinc oxide has wide energy efficiency value, good stability, inhibit oxidation, and low manufacturing costs. And for NCDs, it has good optical properties, high quantum efficiency, and good photocatalytic performance. So we expect the combination of these two materials produce a better photocatalytic performance. As in previous studies, the zinc oxide and CDs composite were applied for many pollutant degradation, like for methylene blue and malachite degradation, and it degrades almost 100% for 30 minutes. And in our research, we applied zinc oxide and CDs for mycobacterial pesticide degradation. Our research objectives are the first one is to find optimum temperature on hydrothermal process for material synthesis of zinc oxide and CDs. And the second one is to analyze the result of photocatalytic activity produced by zinc oxide and CDs photocatalysts for mycobacterial pesticide degradation. And the methodology. Our research stage from the first stage is nanoflowers of zinc oxide synthesis with hydrothermal method, and the second one is NCDD synthesis with hydrothermal method, and the third is the photocatalytic synthesis of zinc NCDs with hydrothermal method, and temperature variation of 100, 120, 140, and 160 degrees Celsius. And then we do pesticide degradation by the photocatalyst, and we use spectroscopy to detecting the mycobacterial concentration. Next. Yes, this is the synthesis of zinc oxide and CDD. Next. And the analysis of zinc oxide and CDD is shown in this figure about diffraction pattern. It has a similar diffraction pattern for each variation and matched with the database of GCPDS number 36, 14, and 51. It has hexagonal word side of crystal structure. So this is magnification diffraction peak at 36.2 degrees. It has different intensity, and the high increasing hydrothermal temperature variation caused more intensity, higher intensity, exception for 160 variation. So this is the crystal size. We calculate the crystal size with Scalar's equation. And this is the morphology for zinc oxide and CDs. The growth of petal is from the increasing hydrothermal temperature cause more petal growth, and the morphology is flower-like morphology, and further size of zinc oxide shown in this slide. This is the photoluminescence spectra for each photocatalyst materials has a peak position, the same peak position, but differs at intensity. And for the good photocatalyst, we need the lower one because the recommendation activity is getting lower, and it's good for a photocatalyst. And the value energy in this left side, PowerPoint presentation, and the increasing hydrothermal temperature makes the value energy wider. So we need the mirror one for a good catalyst. Next. This is the result of degradation of mycobacterial. The profile in the right side shows that the application of zinc oxide and CDs makes the concentration is getting lower. And for negative control is it means that no photocatalyst applied for this treatment. So the conclusion, the synthesis of zinc oxide photocatalyst material and zinc oxide and CDs photocatalyst material was successfully carried out by hydrothermal method, And for optimum result is by single cell NCPDs with 140 variation degraded for 0.42% for 120 minutes under visible light irradiation. Maybe it's enough for I'm sorry if there are any mistakes. Thank you.
Okay, now it's time for discussion. Any question for Ms. Henry? Okay, thank you. Please mention your name and your institution.
Thank you very much. Good morning, everyone. So my name is Sri Jenny. I am from IPB University. My question is, so you combine, so you make composite zeoxide with the NCQs. So what is the source of NCQs? Because that will be the effect of the band gap in between. Thank you.
Thank you, Ms. Marjani. Please answer.
Yes, thank you, Mrs. Sim for the question. I would like to answer the question about the blanket energy. I'm sorry. There are users of NCQs. If the nitrogen source is from Korea, or yeah, Korea, and also from CQs or carbon containers, we use natrium, I'm sorry. Nitrogen source is from Korea, and then the carbon source is from no. Yes.
Thank you, Ms. Marjani. Okay, I'm sorry, thanks. Big applause for Amira from 11 Maret University. Thank you, Amira. Okay, next presenter is Ms. Rimuli Jani from IPB University. Okay, the time is yours. Yes.
Okay, thank you, Madhurata. Thank you very much. Good morning, all participants here. So let me introduce first. My name is Sri Mujini. I am coming from IPB University. So at this time, I would like to deliver this is the result of my research. The title is synthesized heterogeneous catalysts based on green alkyl pharmaceutica for biodiesel products. This next. Okay, so actually this is some of the introduction, the background why I have to do this for biodiesel products. As we know, there's for fuel, a fabricated fuel, and versus the demands. This is thank you. So this is okay. Let me just repeat it. The fuel, as we know, this availability and the demands of fuel here in Indonesia is very not very hectic. I mean, the availability is very low and then the demand is very high. So we have to find out what is the alternative for fuel. So this is really the alternative fuel made from renewable materials, some like alkyl ester or fatty acid. And then why we choose the biodiesel? Because the biodiesel is high certain number, and then also good lubricating power, and also we can say the clean burning air. And then this also photosynthesis biodiesel. This from Director General Energy Barutubakan and also President Energy. This the management of used cooking oil as biodiesel save production cost 35% compared to palm oil. So this is we must to guide the project of the biodiesel. Okay, let us next. So here, the biodiesel is not only biodiesel to produce biodiesel, but we need some catalyst how to get the biodiesel itself. Here, catalyst in biodiesel, we class esterification action. What is the advantage of the homogeneous catalyst? Especially, we use homogeneous catalyst. So this is very disadvantage of homogeneous catalyst, and then form salt and also reduce yield. And then because of that, so we need the catalyst, heterogeneous catalyst. The heterogeneous catalyst we can get from for example, this is we see here a lot of calcium in here, just what eggshell, and then others this is wool, and then others this is some fruit, and then but my research, natural source of heterogeneous catalyst for biodiesel synthesis, we take out from the green alga, Ulpha lactica. As we know, we are the maritime. Look like we are in the maritime countries. This we have a lot of the source, natural source from the deep sea. Okay, so next. And then what is the biodiesel? Biodiesel synthesis can be carried out through reactions. The first one is the esterification reactions. Another one is the trans-esterification reaction. So both are it is good to do to get the biodiesel. Okay. So this is this trans-esterification process. For the step one, the protonation and conversion of methanol, because we add some methanol to the how to get the biodiesel. And then the step two, this is attack on the triglyceride carbonate group. And then after that, cleavage of the CO bond. And then the last step is protonation. This is the trans-esterification process how to get the biodiesel. Here, in this, to get the biodiesel, we use some cooking oil. We can call the Jelantah, I think as commonly. Source of use corn oil, vegetable ghee, and also sometimes animal oil. And then, as we know, side of the dermis to use cooking oil is discoloration and the presence of dirty. Then, this is the some characteristic of the alga. When we use to get the catalyst range, heterogeneous catalyst. This green alga is macroalga belonging to the chlorophyta diseases, and then contains calcium, kalium, magnesium, and then this is potential for a source of heterogeneous catalyst through calcinesis process. So this is the how to get it, we can see that, and this is the synthesized biodiesel method trans-esterifications. We use water bath in this one, and then we'll get the biodiesel and then in the precipitation of glycerol. Result is discussed. Characteristics of used cooking oil. We have two again, the characteristic of use cooking oil first, because it is really hard to do the synthesize the biodiesel. So this is the characteristic of use cooking oil, the density and the free fatty acid in the percentage 1.56. So this study does not require pre-treatment because the free fatty acid is not more than 3%. Okay, and then characteristics of the catalyst. We have to look here that the morphology of catalyst from the A is the catalyst without calcinescence, and then the B is catalyst with calcinescence at a temperature of 550 degrees centigrade, and then the C catalyst with calcinescence 650 degrees centigrade, and then D catalyst with calcinescence 750 degrees centigrade. So we can have a look here that there is some more difference from A, B, C to D. So if we conclude from this result, this more higher the temperature, maybe we can get good catalyst extract. Okay, let me just conclude. Time is up. Sorry. Okay, we can conclude from this research. So green alga has potential as heterogeneous catalyst in the production biodiesel from used cooking oil, and then the last one is optimum conditions here for the trans esterification using calcination temperature catalyst of 550 degrees centigrade. This concentration 2% and trans esterification temperature of 20 degrees centigrade, obtain of material reaching 0.07%. I think that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Okay, now it's time for discussion. Any question? Please. Okay, Mr. Lee.
Terima kasih.
Mention your name and institution.
My name is Nur Cahyo from 11 Maret University. Saya mau tanya dalam bahasa Indonesia. Terakhir, dan bahasa Indonesia adalah bahasa PBB sekarang. Ini. Tadi reaksi transestrifikasi pada 70 derajat Celcius ya, dengan metode reflux ya. Tadi kabarnya reflux. Nah, bagaimana cara mendapatkan suhu 70 dengan metode reflux? Kalau kita kerja pada tekanan kamar itu titik didihnya si sistem itu kan sekitar 465. Kalau untuk dapat 70 itu gimana caranya? Itu aja.
Baik, terima kasih. Bisa bahasa PBB. So, baik, sebetulnya kita bisa mendapatkan suhu itu. Kita refleksnya dimasukkan di dalam bukan penanas, saya menggunakan oli, penanas juga bisa sebetulnya. Jadi sehingga kita menghitung suhu itu pada saat dia mendidih, temperaturnya tetap di 60 sampai 70, bisa sampai 70, bisa seperti itu. Jadi pilih 60 sampai 70. Tapi saya bisa sampai 70. Jadi menggunakan ada memerlukan bantuan, tidak hanya langsung dari flat yang langsung seperti itu.
70 itu suhu panas ya atau suhu sistem reaksi?
Suhu panasnya
ya Pak. Iya.
Oke,
Kalau sistem reaksinya memang 60 sampai 5.
oke,
Iya, iya.
terima kasih.
I think times is up. Okay, big applause for Ms. Martin. Thank you. Okay, then next presenter, Ms. Rina Widya Puspitaningrum from 11 Maret University. The time is yours.
Thank you for the time. Good morning, everyone. It's a pleasure to have opportunity to speak before you today. Let me introduce myself. My name is Lina Widya as chemistry student of 11 Maret University. Today, I'm present to my article entitled Synthesis and Characterization of CuZnO catalyst by active carbon compound. First, introduction. In 2021, the area of oil palm plantation in Indonesia alone has reached 15.5 million hectares. One of the greatest product of oil palm production is oil palm oil because it's contains cellulose, humus, and lignin. Oil palm oil have the potential and active carbon because they have high carbon content of 51% and surface area of 750 square meter per gram. When our tracer suffers in synthesis oil palm we create oil method at 110 degrees Celsius for 224 hours, resulting in a content of 5%. When the carbonization method at 550 degrees Celsius for 3 hours produces a content of 3.8%. Several reasons have used various types of activation with various concentration and found that the use of 20% zinc chloride activator produces as active carbon surface area of 700 to 1,600 square meter per gram. Activator potassium carbon 5% of that surface area of 100-300 square meter per gram. Another activation is microwave where obtained active carbon with a surface area of 800 to 1,800 square meter per gram. The successfully synthesized active carbon show aliphatic CO2 and correspondingly calculate active carbon structure. Punctured cell active carbon can be used as buffer to replace aluminum because active carbon is low cost and also is natural resource. Currently, zinc and copper are used and result in active carbon commonly used in methanol synthesis reaction. Cu metal act as active site to shrink the catalytic process from less metal. Zinc metal act as copper metal that will increase the stability of catalyst. The addition of inverse metal on active carbon using the impregnation method, the Cu and Zn base catalyst were obtained that can use the synthesis metal reaction. Next, the research procedure. Carbonization of PKS radial cell when prepared by heating at 550 degrees for 3 hours. Next, activation with zinc chloride by soaking the carbon with a solution of zinc chloride to obtain a product active. Next, activation with potassium carbonate by soaking the carbon with a solution of calcium carbonate so that the product is obtained with Next, activation with zinc chloride by soaking the carbon with a solution zinc chloride then activate zinc chloride with 600 watt for 8 minutes so that the product name is IGZ. Activation with potassium carbonate by soaking the carbon with potassium carbonate solution the active with microwave in 600 watt power of 8 minutes so that the product name is IGKRB. Catalyst preparation. Impregnation was made by soaking active carbon with carbon solution, adding Cu and Zn metal together to obtain a product named CuZnO catalyst. Calcination by heating the catalyst with a temperature of 350 degrees Celsius for 3 hours and analyze the surface area XRF, SIB, and XMADS. Catalytic tests use interactivity PID reactor test in conditional at the Next. Whenever there is a result, pumpkin is red, color, and has a high hardness. Palm cell carbon is solid red in color. Active carbon is solid red and carbon. The result of proximal analysis showed that all samples had moisture and ash content. When compared with SNE 637301909 feet. The result of the adjusted ultimate analysis showed that active carbon had SNE. Next. The active carbon profile has only two liquid, PL2 theta, 20, 23, and 43 that were repeat indicate that the long-term active carbon produced is above. Next, the highest surface area on potassium carbon active filter. The associated dysfunction isotherapy is active has a hysterosol in it. Type 4 indicate carbon active is mesopause. The picture curve shows that scale active carbon has a super dominant for distribution. Next, CO differentiation P at angle to theta 30 for 38, 61, and 67 degrees indicate that COO has a monoclinic structure. The NO diffraction P were obtained at angles to theta 30, 31, and 34, 36. The indicate that the is crystal has external lucidity. Next, the diffraction of C indicate that C is our carbon. Next, the surface area is smaller than the active carbon due to addition of active metal and comes from an article of explanation with again. The page shows that the catalytic has mixed dominant distribution. The highest CONZ and content in J and anti-MV. The next, the event of catalyst consider irregular particle in mature and case of alcohol still in good distribution means that the active side of the catalyst are more expert the increasing of the catalyst. Next, the activity catalyst can be observed of the reduced or the high or reduction on CU that are not catalyst. Next, the calculation of the structure of HC after activation remain almost with the higher super area in calculation activator and then the structure of the catalytic CU monthly and then which is the surface area of after metal addition decrease the higher CU and then in CU then MV. All catalysts can reduce CU. So this is the reference. It's the reference that we use. My presentation and thank you so much.
Okay, thank you, Ms. Lina. Okay, any question, please? Okay, Ms. Marlian.
Thank you for the opportunity. My name is Mardiana. I'm doing University of Sumatera. I would like to ask you about what the interaction occurred during the activation process. Thank you.
Patient, ZNGL and Capucho-Tiga and like activator and ZNGL and acetate related by water molecule and volatile from the carbon Capucho-Tiga and as chemical agent that promote penetration and contributing reactant and microwaves leading to carbon material, anybody, and even from the inside.
Okay, thank you. Okay, we close for Ms. Lina. Thank you. Now the next presenter is Mr. Ali Darmawan from Diponegoro University. The time is yours.
Assalamualaikum. Thank you very much for the opportunity. I would like to present my lesson about service member presentation. Actually, it's already published in Chemical Education Design. Also, we go from UNS. The idea is we use the one principal material, which is carbon oxide here. Sorry. Graphene oxide is the green module to dot electron to spread between water and salt. The graphene oxide actually, sorry, yeah. This is a light material, which is the 2D material, it is multi-layer and has a lot of functional group, which is actually originated from the graphite. So the functional group like OH, CO, C double bond O, and etc. already has active site that can separate ion from based on the charge, and also the nanochannels of the site also can separate the ion from water. Next. Okay. First, how to synthesize the graphene oxide membrane. Actually, the basic material is graphite. So we are using the Hammer method. Graphite mixed with sulfuric acid and permanganate acid and so on, and that we got the and GO. We try to put we mix the GO with the PPM polymer, and in the bottom, you can see in the bottom. So we put in the nylon sugar, and after that we can put the GO membrane to the cross-link, which is the zinc, and we call the CGO-PPA. And after that, the CGO-PPA it was used to put in the like this one, and in the middle of the O-ring and the membrane, and put it in the desalination setup, which is like this one. The scheme is like this one, and there are two traps to collect the pure water. Next. So in the upper left, it is the GO, which is Black Sea. This layer after the same SEM relationship, you can see that there's like multiple seeds, and you can see there's the much difference between the graphite and the GO for the FAIR, which is you can see there are CO carbonyl, also CO double bond OH, and so on. The peak of the GO is and we can distinguish between the GO and the graphite. And this XRD, we can see the difference between the graphite and GO. So we can conclude that there is we already successful to produce the GO. Next. So after that, we put the GO with we mix the GO with the PA, and it's the upper left is the photo of the membrane in the top of the nylon support, and paradise we got paradise is FDIR and the XRD, and you can see there is like 4 peak here. We can say that solder in the 107 1,700, which is the peak of the sorry, it's the hydroxyl group, right? Also the peak of in the between 3,000 and 3,500 is the increase of the number of the hydroxyl group. It's meant that there is more OH group because of the addition of polyphenol. Also, from the acid study, also we can see the addition of the peak of the area. Next, after that, we try to know the hydrophobicity of the membrane. We can see the upper left side. We can see the addition of the PPA decrease. Yeah, increase the hydrophobicity of the membrane. And also, you can see the picture here that the action of PPA also decrease the state of the PPA, increase the stability. So the pristine GO, the pure GO, you can see only for the 1 minute there will be say breakout. Like for the GO PPA with the cross-linkage until 30 minutes is still just try to break breakout after 30 minutes. So the addition of the PPA cable increase the stability. Okay, next. So this is the final the final result for me. Actually, we try to put the GO membrane for the desalination. This is the artificial seawater. Just put the 3.5% and 7% of the salt in the pure water, and we can see that the membrane can separate water from the solution up to 100%, so close to 100%. With the salt relation, you can say 100%, and the water flux is quite good. It's more than 10. So maybe because we can read the program and the manuscript, it's close to up to 2 kilogram per meter per hour. Actually, it's high, but high flow. So we see that the membrane with GO and PPA actually push membrane to the desalination. This is my explanation. Thank you. Move to the next one. Okay, this is the conclusion. So we can see that GO PPA and GO polyphenol alcohol is quite good with the outstanding performance with the water flux is 20 kilogram per meter square per hour, and complete the salination at 100%. Okay, thank you.
Okay, thank you, Mr. Adi. Any question? Please boleh dalam bahasa Indonesia. Okay. Silakan.
Thank you. So this is very interesting research, also within the membrane itself. The question is, so you put the GO and PPA places in the
It is nylon spot.
nylon spot. Oh, okay. How do you get, how do you bring them compact each other?
So actually, can you say the page number 3 or page number 4? Actually, this just put in the how to say. Yeah, there is polyphenol, and you just put the solution of GO and the solution of PPA. Put it, and we with the bottom pump. After that, the GO will be deposited on the top of the and the vegetable pool. Yeah, the cross-linking we are using the chloride as the cross-linking. Not blue, but cross-linking. Yeah, cross-linking. Yes, so you can say that it's very stable, and the thing is, in sonication, that's how to say, pull the rays not up. So the slide number, maybe next slide. Next slide. This one. In the bottom left. Yes, zinc chloride. Yes, we can use like carboxylic acid. I'm sorry. Yes, you can use like metals also another polymer also using the yes. No. For the no, just put it in here and sorry, this is maybe only 80 degrees. Yeah. Yes, yes, to make it perfect. Yes, to make it perfect. Yes, yeah. My own is 80 degrees. Like not more than 100. Yes, yes.
Thank you, Ms. Marjani. Thank you, Adi. Nice. Okay, we applause from Mr. Ahli Dewan. Okay, presenter Ms. Mardiana from 11 Maret University. Okay, the time is yours.
Okay, thank you for the time. My name is Mardiana from University of 11 Maret, and I would like to present my review paper about catalytic hydrodesulfonation in biogas reaction with the light-based support. Next. Okay. From the data, based on data from Outlook Energy Indonesia, total energy supply of Indonesia consume about 48% fossil fuel, and transportation sector consume about 37% energy, and also produce about 22% of carbon dioxide emission. So to replace the demand of the fossil fuel and also decrease the greenhouse gases emission, we can use the biofuel as renewable energy. One of them is biogasoline. But generally, biogasoline is produced from the pyrolysis process, which is a high oxygenate compound and can lower the quality of biogasoline, such as low heating value, thermal and chemical instability, corrosivity to the engine, immiscibility of fossil fuel, and also polymerization tendency. So to increase the quality of biogasoline and also remove the oxygenate compound in biogasoline, we can do the hydroxygenation or HGO process. Next. Okay, HGO process is generally done to produce the biofuels such as green diesel, jet fuel, and also biogasoline. And it can occur by the assistance of the catalyst, which is the functional catalyst, is widely used because it contains metal side and also support. And zeolite is widely used because of its characteristic. So in this review, I will focus on biogasoline, HGO process, and also the functional catalyst, and also zeolite. Next. Okay, biogasoline is the hydrocarbon with atom carbon in the range 5 to 12. It is derived from biomass, edible and or non-edible vegetable oil, and also biomass waste. It contains the main compound BTX, which is benzene, toluene, and xylene, and also mixture of phenol, which is paraffin, isoparaffin, olefin, naphthalene, and also aromatic. And the advantage of biogasoline is the properties is similar to the conventional gasoline. So the modification in the engine is not needed. Next. Okay, this is the summarize of the biogasoline production and its challenge. As we can see from the table 1, the result from the catalytic cracking and also pyrolysis process is contained oxygenate compound. Next. So to remove the oxygenate compound, we can do the hydrooxygenation process, which is the hydrotreatment process that can remove the oxygenate compound by the cleavage of carbon and oxygen atom by the presence of hydrogen. The process of oxygen removal can occur to hydrogenolysis, dehydration, carboxylation, and also decarbonylation, as we can see here. Yes. Okay, and the determination of the performance in HDO process, we can compare the weight of oxygenate species in the product with the oxygenate species in the feed, and also can compare the physical-chemical properties with fossil fuels. We also can measure the hydrogen carbon and carbon oxygen ratio in the product, and we also can evaluate the compound shape via GCMS. Next. So, bifunctional catalyst contain metal side and also the support, but in this review I will focus on zeolite. So the synergistic effect between the metal and zeolite is not found in the another catalyst type of catalyst. Metal side, as reported by Wang, Duo, and Wang Dongsapu, is important to absorb the oxygenate compound and initiate the cleavage of CO bond. And for zeolite support, it contains high surface area, selective for acidity and thermal stability, which is contained BAS, Bronson acid site, and also LAS, Lewis acid site. And the BAS and LAS depend on the FeRl ratio. And FeRl ratio also affect the acidity and affect the surface area. Next. Okay, one of the most used type of zeolite is ZSM5, which is pen membrane, and it has a selective pore. And we can see from figure 4 the mechanism in HDO of pyrolysis oil of fresh palm fruit to NPH ZSM5 catalyst, and the mechanism through the absorption and also the dehydration process. Next. And there's also morganite. It has 12 membrane, which is the pore is larger than the M5, as we can see from the research from Pulungan. We can see that the surface area for balloon and also average pore diameter is possible to use as support. Next. And also natural zeolite. 40 types of zeolite is found in the natural zeolite, but in Indonesian natural zeolite, the highest component is clinoptilolite and also zeolite. Next. And table 4 summarizes the HDO process with different bifunctional catalysts. As we can see from the table, that the product distribution not only depends on the operation conditions such as temperature, pressure, and the reactor, but also the catalyst, the type of the support, and also the FeRl ratio. So for the conclusion, biogasoline can we can improve the biogasoline by HDO process with the assistance of bifunctional catalysts, which is the zeolite-based support such as the ZSM5, morganite, and also zeolite have good potential as support due to their high surface area, selective pore, and acidity. Next. This is several references that I use this paper. Okay, thank you so much for your attention.
Okay, thank you, Ms. Mardiana. Any question? Okay. Please, your name and statements.
Thank you for this opportunity. My name is Nina Rifatul Aziza from Sofia University. The question is, what parameters need to be considered to improve the selectivity of biodiesel? Okay, thank you for the question, Ms. Nina. Mungkin boleh kembali ke tabel 4. Mr. Yeah, yes. Okay. Maybe we can see from the table 4 that the parameter we should focus is not only from the resolution, but we can adjust the temperature, the pressure, the reactor, and also the type of catalyst, including type of support and also the SDIL ratio in support.
Okay. Thank you, Ms. Mardiana. Can you pick up those for Ms. Mardiana?
Thank you so much for the question.
And the next presenter is Mr. Muhammad Istira Aziz from ITB. Okay, not listen. Okay, next presenter, Ms. Sekar Ayu Farida Ali from Diponegoro University.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. So, right now, here, hi everyone, my name is Maria Ali. You can call me Scott. I'm from Diponegoro University from chemistry major. So here, I want to present about my research. It is computational study of the stability of vitamin C on the effect of solvent and temperatures compared with experimental results. So this is the introduction of my research. As you all know, approximately 5% of the world's adults has dementia. The global prevalence rate among individuals over the age of 40 is 6.7%. A new case in ischemic stroke diagnosed every 40 seconds. Ischemic stroke and vascular dementia are common cerebrovascular diseases that are related. Stroke survivors are at high risk of developing dementia, especially the vascular type, which is caused by damage to blood vessels in the brain. Blood vessel damage in the brain is often triggered by damage of the blood-brain barrier. The BBB acts as a protector of brain parenchyma by regulating the flow of substances through the cerebellum endothelium. A damaged BBB allows harmful substances, including pathogens and toxins, to enter the brain. If there are harmful substances in the brain, it can trigger the inflammatory response and oxidative stress. Oxidative stress can occur due to the imbalance between the production of peroxidant and antioxidant. Oxidative stress plays a role in neurodegenerative disease. There are many sources of ROS, but mitochondria are the main contributors of ROS in the body. ROS are toxic due to the presence of unfair active electron. If these ROS appear in uncontrolled amounts, they will cause damage to all macromolecules and affect cells and body tissues. The toxic effect of ROS can be limited by providing additional body defense using antioxidants such as vitamin C. Vitamin C is a water-soluble electron acceptor that protects membrane from excess radical buildup due to degradation. So vitamin C is needed to blood vessel development, iron absorption, and anti-inflammatory activities. Vitamin C is a natural antioxidant that shows the most potent antioxidant properties by reducing superoxide production. In addition, vitamin C is better at stimulating catalysis activity when compared to other antioxidants. Vitamin C is not only important for maintaining redox balance, but the absence of vitamin C in the brain can affect nerve function and integrity. High consumption of vitamin C lower risk of dementia. Therefore, we can go to the next slide. Therefore, vitamin C has the potential to be used as an active ingredient in the drugs. Vitamin C has the weakness that it is easily oxidized due to the influence of heavy metals, oxygen, light temperature, heat, and pH, and also interact with other components so that the benefits of vitamin C are less than optimal. Degradation of vitamin C can reduce the effectiveness and quality of the products. Research by Sarkar that encapsulated polylactide film in vitamin C can protect brain mitochondria better against oxidative components that encapsulated vitamin C. In general, the stability of molecule in different solvent is important in the drug manufacturing industry, especially during the characterization process for purification and preparation of solid drugs. Experimental investigation of vitamin C stability data are extensive and quite specific activities. Quantum studies can be used to predict environmental conditions such as solvent and temperature that affect the stability of vitamin C, making it easier to design storage formulation and use of activity drugs ingredient to be optimal when used. Structural analysis, microscopy, and stability of vitamin C were chosen to increase a deeper understanding of the best way to maintain vitamin C stability and its application in various urban everyday life. Research into computational chemistry method and their comparison with experimental results is expected to provide useful innovation in studies. Next slide. So this is the research method that I use. There are some materials. Experimentally, I use in the distilled water and so on, and then the tools. Mainly, I use UV spectroscopy and FTIR, and then also computational chemistry. Next slide. This is the methodology that I use. So first thing I do is determine the vitamin C functional group for a week, and then determination of baseline of vitamin C with solvent correction for a week using UV spectra, and then the structure preparation stage vitamin C using a DFT method, and then geometric optimization of vitamin C, calculation of the TD, vitamin C, and then analysis of the result. Can you go to the next slide? And this the data experiment. There is the black one is vitamin C fresh, and then the red one is vitamin C in it shows. So it is shown in the graph figure that transmittance in from fresh vitamin C to 1 week vitamin C is very low. So there are some degradation in vitamin C. Next slide. And this is the stability of vitamin C using TDF using the FE method. In this video, we show that in the right one, there are ascorbic acid. When it's unstable, they tend to loses its H atom in the ultra, and then they change or degrade into monoammonium ascorbate. And then they degrade again, losing its H atom, or making new molecule monodehydroascorbate, and then changes into dehydroascorbate. So this next slide. So this is the UV spectra that I use using solvent water. Next slide. This is the summary of chemistry using UV using methanol solvent. Next slide. This is the whole graph. We know that the acetone is the lowest has the lowest energy. So acetone is the one that is more stable than water. And then next slide. Bringing this to the conclusion. So the conclusion for my research is based on the changes in ER and UV spectra over a week. It is predicted that fatty degrades during storage. Ascorbic acid converts to intermediate molecules such as ascorbate and ion and monodehydroascorbate, eventually forming dehydroascorbate. Solvents significantly affect pregnancy stability. With acetone providing the most stability is followed by ethanol, methanol, dimethyl, and water. With water offers low stability despite being a common solvent. Computational chemistry shows that pregnancy is more stable in lower temperatures. The combination of experimental and computational chemistry is crucial, as experiments provide data for validation, while computational method offers predictive insight, leading to enhanced accuracy in fields like drug discovery and material science. So I think that's all that I can speak. Thank you for your attention.
Okay, thank you. Next, any question from audience? One question. Okay. Please mention your name and city.
Okay, I'm Kausar from Unmar University. Okay, do you have programmed conformational analysis from before calculating UV spectrum?
Can you, misalnya I don't get the question, can you make it simple?
Bisa dalam bahasa Indonesia.
Oke, berarti begini gini, apakah Anda sudah melakukan analisis konformasi sebelum menganalisis spektra seperti yang mungkin kita ketahui apabila suatu senyawa itu dalam bentuk larutan, apalagi vitamin C yang memiliki banyak stabilitas dalam molekulnya, itu bisa banyak konformer seperti itu.
So I did the research by searching in the journal and then find the best way of liberating vitamin C. Like, I just using the journal that the best potential that vitamin C is liberating. So not really using any other one.
Okay, thank you, Ms. Nanti, because for Ms. Okay, presenter have presented their research. Thank you very much for your attention in this parallel room. I apologize if there are many mistakes as in this parallel session. Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Big applause for us. Isi kursi lebih yang paling depan terlebih dahulu. Sekali lagi kami mohon Agar dapat mengisi kursi yang paling depan terlebih dahulu. Terima kasih. To sale at the restaurant tables in the main hall because of the awards. The conference will proceed immediately. Please be still. And to begin this conference, we would like to invite you to present your mobile phone inside that. And please kindly to see the front seat first. Thank you.
To the Honorable attendees, we are coming to the first agenda. Welcome to plenary session 1 of the Joint Conference on Chemistry 2024. In this session, we are honored to have Professor Claudio Tiribelli, who will share his insight and expertise with us. To guide this session, we are pleased to have Professor Witri Wahyu Lestari as our moderator. Professor Witri Wahyu Lestari is a renowned scholar in her field and will facilitate today's plenary. To Professor Witri Wahyu Lestari, please come to the stage.
Ladies and gentlemen, before we begin our planning sessions, please be seated. And to begin this conference, also would like to invite you please kindly to sit in the front seat first. Okay, please, Professor Witri, to begin the conference of planning session 1. Thank you.
Yes, thank you for the MC. As our ceremony, the introduction. Good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. First of all, here, I would like to introduce our first plenary speaker. He is Professor Claudio Tiribelli. He is Scientific Director of Fondazione Italiana Fegato Onlus, or in English we call Italian Liver Foundation, and he was born in Mestre, Italy, in 1946. Claudio Tiribelli graduated in medicine and surgery at the University of Padua and specialized in gastroenterology at the University of Trieste, Italy. From 1989 to 2008, he was full professor of clinical biochemistry, and from 2009 to 2016, he was full professor of gastroenterology. As an expert hepatologist, he is known above all for his studies on bilirubin, and in particular on admixtures. neurological is induced by bilirubin. He is worldwide expert in wide spectrum of liver-related diseases, from fatty liver fibrosis to liver cancer. He is the creator and still scientific director of Italian Liver Foundation, NPU, based at Area Science Park in Pesovita, a reality of international excellence in translational hepatological research. He has more than 400 original articles, reviews, and editorial in very few journals, and as well as a book chapter with more than 30,000 citations. It's index 82. Now, Dr. you have 30 minutes for deliver your speech. Yes, you can please.
Also, BB, thank you for this introduction. Well, thank you very much for having me here. Unfortunately, my stay will be very short, but I can try to manage that way because I will change the schedule. My presentation is going to add something on drug delivery system for cancer. The question is why doctor dealing with cancer and the patients being invited into the cancer meeting. The question is that what I'm trying to do today is try to make a marriage, a very free marriage between chemistry and medicine. But I think the more we are going on with science, the more we understand the interaction between them and the interaction between medicine and chemistry, the sciences will make life better for ourselves and our human beings. Let me try to start with what about the liver? The liver is the largest organ in our body. It's one of the two organs together with the brain to be simple. And the liver has been considered in the ancient times the place where life is lived. Actually, if you go back in the ancient times, when the Rishis are opening the sacrifice animal to look here, liver was the first one to be. Liver has several functions, such as clearing toxins, get rid from the old blood cells, make bile, and the most important, liver is the only organ able to move a compound is lipophilic to something is hydrophilic, which means actually the way actually liver is getting rid of a lot of drugs and toxins. The liver cancer is something which is usually at the end of a long journey. Long journey starting from the liver and going to different stages, such as chronic disease, such as and then fibrosis and so on. Usually the trip from healthy liver to healthy takes around 30 years. So we need to understand where the liver starts in order to prevent the progression. And the journey starts with the several hints, such as hepatitis, B, C, fatty liver or alcohol, metabolic disease, and other things. But this is most important we need to understand. We need to also have the possibility to skip the fibrosis and cirrhosis, go directly from the property to service. This particular true course. So we need to be very careful of that. But once we have the cancer, we need to treat the case. And if you look back in the time, these are for hepatitis B, 3 countries like China, India, and Indonesia, represent more than 50% of the global burden of disease. And this is something which is very scary because this should be prevented
need to have treatment for this disease. Liver cancer, the global, the incidence is the sixth more prevalent cancer in the world, accounting for about 1 million cases per year. And the human mortality is the third count, also accounting for about 800,000 deaths a year. So liver cancer is the three comes at the top cases of liver cancer. So we need to consider this and then we try to treat it. And if you look at the geography of it, we may realize that it's very much with our friends in Europe and India and all over the world. There are some countries with a very present, particularly in Africa, in the Central Africa, and also in Indonesia, China, and Thailand. There's a lot of COVID. And this is because the prevalence of hepatitis B in the country. In Italy, for instance, the liver cancer is number 11 in terms of the cause of death, but number 6 males. In Indonesia, it's number 4, and the second cause of death in males. So we are dealing with something which actually is important, both in terms of general health, but also in terms of money and cost. So we need to have guidelines. The guidelines are that we must realize that the guidelines we have now are not the curative for most of the patients because we don't have the possibility to fund the administration. And since we look at the patients at the late stage, we need to have some specific treatment in order to prevent and even to cure it. How to make it? We need to have target therapy. Target therapy, we need to discover the target molecules as well. And we develop new drug delivery system, which say, and we have also to assess the specificity and efficacy of it. So let's try to concentrate on development drug delivery system, which is the drug development is a very multidisciplinary event, involving chemistry, medicine, biology, and social economics. And because in order to have a new drug, we need to have a sort of specific bring together and try to end up with something which and we also need to rely on the access of labor. There is a time-consuming and very expensive process, and we need to maximize the outcome of it. So, what about drug delivery? Drug delivery is the way to actually try to deliver the drug where it's needed, rather than to deliver it to the whole body. This is for two reasons. Number one, it reduces extremely the side effects, which with cancer are very high. The second, improve the outcome by reducing it. So we need to do it by this particular distribution, to be selected in the wrong country, to have a low resistance, to maximize the outcome, and even more important, to have a low toxicity in non-disease organs. For example, if you treat patients, for instance, with doxorubicin, you have some effect on the liver, but you have a high effect, which means that this prevents the treatment with doxorubicin to all the patients more than 70 years old, which are the old present cases. So we also need to understand that cancer is not a simple environment. It's a very complicated story because we have several different cells working together and interacting together. And we need to actually develop a way in order to eat the cancer cells, naturally spare the no-cancer cells, in order to remove and minimize the side effect. And this is particularly important because we need also to understand that within the cancer, particularly the liver cancer, we have a lot of cancer stem cells, which actually are the cells which once the mature cells are killed by treatment can survive, can reproduce the condition in a short time. So it's a very complicated story, where we need to have the possibility to hit what we need to be hidden. You need to have the liver of the drug into the capital. It's like when you order a pizza, I mean, the pizza should be delivered to your place, it should not be delivered to the place close to you, because this is going to be something which cannot be happen. So, how can we do it? First of all, we have the classical drug delivery. I give drug to the patient, and I try to understand the system is responding to the drug. Other possibility, which actually is to deliver the drug loaded in some particles. So, and another particles has several advantages, such as stability, almost specificity to delivery. So we need to obtain a high intracellular uptake, and actually to have a sort of ratio between specific and unspecific delivery, which are specific. And this is what we are, and this is what we are doing and trying to enhance the tumor uptake by either intratumoral injection in order to minimize the tumoral delivery of the system. We can do it by passive targeting, so have the evident action in a particle distributing the permeability of the blood vessels. We can also do by active targeting, making a sort of target of the particles. And then we can also activate the nanoparticles once inside the cell. And altogether, this makes possible to understand what we can do by nanoparticles in the target structures. And this is two examples. One is the passive targeting, the other is active. Passive targeting mainly depends on the permeability of the blood vessel. For instance, there is a blood-brain barrier highly impermeable to the passage of nanoparticles. So we need not to be very much concerned about the possibility of our drug to break. On the contrary, the liver is rather permeable than the syndrome, but as liver is also other organs like kidney or lungs are also permeable. It means that the passive targeting is an example to focus our delivery of the target of the brain of the drug into our body. On the contrary, we can have some active targeting. Active targeting means the agents I'm studying or delivering can be directed where the surface is located, minimizing the non-specific uptake by untargeted cells to a great extent. So we need to work on that, and we need to understand which is the target, because this is where I have to aim my drug to the liver. And we have different strategies. We have surface, material properties, cell peptide, vaporization, cell coating, and that's it. Or targets such as carbohydrates, which shows an example of that, antibodies, receptors, and vitamins, or optimals. All together, by playing around with the structure of different platforms, we can achieve more or less a very successful delivery of the drug that is needed. In addition to the coating and to the target, we can have also some options by playing with size, shape, and charge, in order to make possible to have a specific delivery of the drug where the drug is needed. So, what about the drugs for cancer therapy? The first report of a specific a drug against liver cancer is being back in the 90s when the FDA approved by the possibility to use doxorubicin and levers of injection is so specific treatment. This was passively targeted. And we know this has not been so much successful because the specificity of the toxin of the liver solution has been achieved. And you see here that there are several clinical trials ongoing, still ongoing, on the possibility to target this drug to other drugs to episodes. This is a list of different ongoing trials. And you may see that all of them are in phase between 1, 2, and 3, meaning the phase 3 is the closest to the clinical application. And you know, you see that there's an optimal study, generally sensitive library, which actually appears to be rather positive in terms of specificity, but the results way out. In addition, we can use also the particles to deliver not only drugs, but also microRNA in order to try to interfere with the metabolism of the liver cells, particularly the cells with the cancerous signal. So basically, what we are dealing with is actually trying to understand what we are dealing with. And then we discovered that there is a great possibility. The liver cell is the only cell only at the surface, the so-called ASGPR, which stands for alpha-hydroxy receptor. This receptor is specific for the liver cell, even more expressed in the cancer cell. So I think that this may be one way to go. And it's an example also to show that the alpha-hydroxy protein is highly expressed in hepatocellular carcinoma as compared to adjacent. So we can try to help this delivery by a galactose-mediated delivery of our drug, specifically to the liver and in particular to the ACC cell. So in order to prevent an effect on the adjacent cells, even more important of the whole. And this is what has been demonstrated in a paper published almost 2 years ago, when the Chinese worked in the possibility to have nanoparticles with the target of specific drug of sorafenib and glucocorticoid via a alpha-hydroxy receptor through a specific lectin cell. I'm not a chemist, so I mean, you have to forgive me that I'm going to be so specific on that, but I'm expert in the room. This is much more than me. All the chemical and the mechanical. But what is here depicted is what they did. So they had a sort of sorafenib, glucocorticoid, sampled in a nanoparticle, and then covered by a galactose and rubicin to have the fluorescence, and then have all this loaded into before doing this, they did something which is important. They gave this drug to them. You may see that the difference between the upper panel and the lower panel is the presence of the absence of the glucose of the galactose that we receptor. And you may see that in the case of the galactose receptor, there is a clear accumulation of the drug in the liver, and even more important, the tumor size is reduced rapidly as compared to either sorafenib or glucocorticoid, suggesting that at least in the rat, this drug may be beneficial. We still don't have any clinical data because we're still going, but this appears to be very promising in terms. We can have also we can have also another approach. And this approach we are taking up study. And due to the fact that we have we had the possibility to work with Gisela. Gisela was a researcher working at AMPA in Argentina, who came to our lab with a good idea. The good idea, they created a new drug. The new drug is a sort of a 4-methylphenidone here, which is known to be an anti-drug. But actually, they link this with sort of with aspirin, which actually was a sort of transaction with beta glucose, making it possible to absorb target drug, which is actually interacting with the asylum protein receptor. Gisela came forward that it is some experiment in cells and in mice during the chemo. But even more importantly, first cleared the idea in vitro. We may see that in 2 different cell lines derived from age 6 or age 7, the difference between the glycosylated for U and the non-glycosylated for a U drug is astronomical. So meaning that you really you had the possibility to deliver the drug and the drug is completed. And this is the outcome in terms of tumor size. You may see that there is a significant difference between saline for a new and for blue. And even more important, if you take the survival rate after each injection of cancer cells, you may see that saline after 15 days, all the mice die. To the contrary, when you treat it with more, you have a survival rate of 100% after 15 days. Second, is maybe very good. But now, together now, we are trying to understand whether it could be possible to have a phase 1 trial as well. The issue is that we need to have the reduction drug high enough to be used in the patients. We are waiting on them to let them to raise this possibility. Okay, folks. Now, what are the advantages and disadvantages of the so-called nanomaterial structure? Several advantages I told you before. Structural release, valuable, speciality, simple prescription of the functional control. The actual also disadvantages with the ribosome distribution, ex vivo, the polymers, the response, the dendritous reaction. So we still are away from understand the real benefit, the pros and the cons of the different parts. But by looking at that, we are understanding that in the future, we can really have a sort of specific bullet to hit the cancer and spare the surrounding. Cells. No. Okay. Now, next. So where are the challenges? Next. As I told you, cancer carcinoma is a widespread disease, costing lives because of it. You also have to realize that integration is expensive, so we need to have a better about the background in order to understand whether we can personalize it. And now in medicine, we're more and more getting into the so one size doesn't need to have one treatment specific for each patient. And we need to understand it better. This is why we need to actually, first of all, understand which are the needs of each patient in order to modify treatment. And this is also because, as I told you, the development of the drug is a very costly and long-standing process. This is basically, what's being reported, the cost of the link of the drug. You may see that the cost is, and this is why you need to understand that this may be due only to the big farmers, which actually can invest billions of dollars to use in order to have this possibility delivered to the patient. And this is where we need also to understand to the development, which actually takes time. It also takes a lot of time to go from drug discovery to the phase of it's about between 4%. And if you then make a sort of post-market drug safety, there are different ones to use. It's all together. When you have your drug from in the lab, like moving to the patient, and also makes possible that only few drugs, what we start with, maybe the right drug, the right drug, or the right drugs to be used. So altogether, we need to understand that we are still facing a lot of uncertainty. The future of that. So what we can do together, you see here a picture of the chairman, together with Cecil and supervisor, senior senior scientist in our foundation. Our chairman came to this town last and did some work with Cecil. So we are sort of linked between US and this university. And I think that the future may provide some interesting things. And there are programs going on. There was some drug, the smuggle and custom drugs from US to Indonesia. And we are looking forward to receiving the results. Here we are the perspective. So we need to have something that's actually only to the drug, but also can prevent drug that we have to place in the future. And this will be possible with the support of a lot of different entities, like the Liberty Development Foundation, our university, great, we have to support it, assess it, university. It's actually support the idea. Let me finish my presentation by showing the ACC group in our presentation, chaired by Cecil, in front of the other fellows, and back of our team. Thank you very much for your attention. I'll be delighted to respond.
Thank you very much about the recent advances in the clinical system of different cancer therapy. Now I will offer the question for 5 minutes because he has to. What's that, please?
Okay, thank you. There are two concepts that I'm thinking dealing with the drug delivery of nanoparticle drug delivery. One is about the stability. It might result in less targeted efficiency. Because nothing is possible that the drug delivery when administered, partial degradation occur. Partial degradation by body fluid. It might result in less targeted efficiency. And the second one is dealing with the adherence. Because it is possible when administered in the body, when it is recognized as foreign substance, the immune system will release the drug. So it may result also in less efficiency. What do you think of this issue? Thank you.
Well, thank you for your question. It's well taken question. Regarding the clearance, I agree with you. The clearance should be implemented. The only way to get clearance is to target. Actually, to have a sort of a anchor in the nanoparticle in order to deliver the drug where it's can be done either by the particles or the slide plant itself. for glyphosate we're looking at maybe one way to go. The other, that's decay of stability, something we have to take into consideration. Whether this is supposed to be solved, I doubt. I'm not a chemist, but I understand that this is an issue. But this is the same issue we have almost all the drugs. Basically. If you give a drug, the stability of the drug may be long, may be short. In any case, the drug becomes less effective and efficient because it's a clearance, because it's a lot of stuff. And we have to start with this. This is one issue. If anyone dealing with nanoparticles and drug therapy, should any. So,
Again, open one more question. If you don't. Is there any question? If not, I will ask on the submission.
you are entitled to.
The letter is specific properties of these liver cancers if we compare with the other cancers and how this property.
Well, of course, liver cancer cells are different from this. Lung cancer cell or lung cancer cell or kidney cancer. And this is where we need to take advantage of this diversity in order to play around with the drug target. For instance, as I showed you, in the episode of carcinoma in the liver, is the only organ that has iodine receptor. This may be one way to go. For instance, in the kidney, there are other receptors which are specific for the kidney, and people and researchers dealing with renal carcinoma are doing this. So that's exactly what I try to explain to you. We need to have one drug for each organ. Let's put it this way. But again, I mean the term carcinoma is like one episode carcinoma is not exactly like the other, and then this means that each cancer is so complicated by itself that each cancer stands by itself. So one treatment I'm delivering, one treatment I'm spraying already, improving properly may be useful for a percentage of the patients. And this is where is the big challenge. I know to understand beforehand which is the response, which is the expected response of the patients in order to treat the dose and the drug to the patient. That's what it is. Personalized medicine. So,
if there is no question, then I will close the session and I can conclude that there is a close relationship between chemistry and medicine, biomedicine. That's why as a chemist, it's a big opportunity for us how to implement the patient.
thank you very much.
Okay. Thank you very much. From very on the next and I will call the second panel speaker. Prof. David, there is a certificate for me.
Ladies and gentlemen, we will present a certificate and souvenir to our esteemed conference presenter as a appreciation for their valuable contribution to the conference. To present the certificate, I would like to invite the chairman of organizing committee, Professor Armando Heruibowo. Professor Armando Heruibowo, please welcome to the stage. And to Professor Claudio Trivelli, please welcome to the stage.
the next talk and yes, and then I will call the second speaker, Professor Eddie Energy. Professor Eddie Energy is a distinguished professor in the chemistry department at University of Denmark with a proper expertise in solid state chemistry and analysis. This company is Eddie Energy. In this session, we will speak about utilization of low-cost potential resources for strawberry production. Before we get into this piece, I will read some introduction about him. He is Professor at University of Denmark in the solid state chemistry and catalysis, and he has made significant contribution to the field of both his research and teaching. This work primarily focuses on the development and optimization of catalytic processes, which are crucial for various industrial applications. Professor research in solid state chemistry has led to advancement in understanding the properties and behavior of solid materials, leading to innovative solutions to material science and engineering. Professor's contribution has not only enhanced the academic community at University of Denmark, but have also had a broader impact in the global scientific community. This work continues to inspire the great progress in the field of solid state analysis. Literally, you will have 30 minutes to take for your space, and then we will continue with the next
Okay, thank you very much, Moderator. I think should be very long on me. Okay, I want to thank you very much for the first good morning, ladies and gentlemen. This time, I would like to present my presentation about the utilization of low-cost magnesium sources for sulfide production. So as we know, in wastewater treatment, if we want to phosphor recovery and also ammonium recovery or ammonium removal, we can produce the sulfide formation or sulfide production in the water treatment plant. So if there is, okay, next, yeah, next, yeah, oh, yeah, this one, sorry. Okay, sulfide is a compound of magnesium ammonium phosphate. We can stand for MAP. Yeah, it's a crystal that can occur naturally or synthetically. If we have phosphate or phosphor ions, and then we have ammonium ions, and then we have magnesium. So in a certain pH, we can produce sulfide material. So it's very easy. And for this production, we no need the high temperature. Yeah. So in the room temperature, we can make the sulfide This is one of my interesting for my research due to the production is very simple. No need temperature high or no need high temperature. If you have some ions, ammonia, iron, and phosphate ions, yeah, we can mixture in the room temperature, so we can production magnesium phosphate, or we call sulfide. So this is very simple. One of the method to production, one of the method is chemical precipitation. Yeah, chemical precipitation, I think is one of method. It's simple. So we need pH treat and also molar ratio. Next. Yeah. Sulfide is a white to yellow mica-like crystal with high potential application as fertilizer and adsorbent. The final goal, if we want to sulfide production, we can application as fertilizer and also adsorbent, specifically for heavy metals absorption. So sulfide formation are highly dependent on the ion composition that I have told you before. Temperature, yeah. There is a researcher using variation of temperature. I can say there is using 60 until 80 degrees Celsius to make or to sulfide production. The important thing that I have said before is pH and then ion speciation characteristic. If there is magnesium in our system, so we can think, what about the calcium? The calcium influence may be it's very important too, because we know the calcium ion with magnesium ion is it's competitor. So the similar characteristic I think can make influence if you want to survive production. Next. Yeah. The physicochemical properties of sulfide crystal, we can look, you can see in our presentation. Yeah. The composition, magnesium only 10.73%, and then there's phosphorus, hydrogen, etc. Yeah. Why we use the magnesium, or why we want to alternative to magnesium sources to make the sulfide production. Yeah, because the magnesium is very expensive. Yeah. For example, if we use the magnesium chloride or we use the magnesium sulfide, maybe, yeah, it's very expensive. So many researchers want to have tried the experiment or the research using the low cost of magnesium from the others. Next. Yeah. The background for the title today, we have published sulfide production in Journal of Environmental Chemical Engineering in 2017, but after I explore this thing, I didn't know. No. Yeah, I see there is a researcher still using or still looking for magnesium sources for alternative magnesium to make the sulfide production. And then I have get the article in 2024 in June, maybe. So now we want to see the different or the same two presentation to make a comparison to article in here. Next. Yeah. Why we need magnesium source? Because iron magnesium is usually lacking in urban sewage. Yeah. So we need an external magnesium source must be added for sulfide precipitation to occur. The commonly used magnesium sources is magnesium carbonate, magnesium sulfide, magnesium oxide, magnesium hydroxide, and magnesium chloride. Yeah, we can see in the figure. Yeah, we look. Before previous slide. No. Before this. Okay. Yeah. We look. Yeah. Phosphor ions, ammonium ions, and magnesium ions. So we look the pH. Yeah. So sulfide will be production at the high pH. Yeah, in the basic pH. Next. So why we need the magnesium alternative, magnesium source alternative to change the to change and to lower the cost. So we have to alternative, in some natural magnesium sources which has found potential to precipitate sulfide are as, so there is dusite, there is dolomite, there is beacon, there is brine or seawater, and also we have desalination waste. In Central Java, there is a big electricity plant, in Japan, in Pekalongan, in Semarang, that using the seawater to production water stream. So we must try to several some natural magnesium sources. Okay, research has shown that the addition of low-cost magnesium sources can significantly reduce the cost of producing sulfide between 18 to 81%. Next. Seawater, as we know, the big amount in the sea, seawater with approximately 1,100 milligram per liter of iron magnesium is seen as promising and economically viable magnesium resources for sulfide recovery. Another low-cost magnesium source is brine water. Brine water. We call too as the desalination waste. It's the desalination waste which is richer and more environmentally sustainable alternative. We now during the process seawater to clean water in the steam power plant. After seawater, we make this out. So this waste from desalination process. If we do not use the waste of desalination, I think it's very kalau sayang itu bahasa unfortunately jadi so we have to, or I have to think, I want to using the desalination waste for magnesium ions resources to make the sulfide production. Next. The interaction magnesium ammonium phosphate, you can see, it's very simple. Another sulfide we may production with Newberry, Bobby added, and so on. So the pH must be high. Yeah. pH must bigger than 7. Next. Yeah. This is sterilization parameters. In the left figure, you can see how to localization, yeah, growth area and dissolution area. Next. Yeah. Calcium ions very influence survival crystallization. So calcium ion have been shown to influence sulfide crystallization by calcium phosphate precipitation. Higher calcium concentration can lead to complexation of calcium and phosphate species and reduce the activity of precursor ions in the reaction medium, or even result in simultaneous precipitation of calcium phosphate mineral. Next.
5 minutes.
No. Finish.
5 minutes.
Yeah. 5 minutes, yeah, okay. Yeah. Brock Hartz et al. In 2021 have research how to precipitate from in the control the structure of sulfide. So sulfide include the autonomic structure. Yeah, you can see in the figure C there is irregular reddish particle. Yeah. Okay, next. Yeah. In the left is the Broadhart et al. Yeah, desalination, and in the right hand, our team investigated the sulfide that produce at pH 9 in molar ratio magnesium, nitrogen, and phosphorus for A 111 or B 112 and for C 121. Next. Yeah. But at all in 2024 in Desalination and Water Treatment Journal have published, and he saw the phosphorus recovery measure in the experiment equilibrium theoretical phosphorus recovery at pH 9.5 and different magnesium phosphor molar ratio. So we can look it's similar results. Yeah. Next. This is at molar ratio 1.5. So the higher molar ratio, this phosphate recovery in low pH it's very little, but in the pH 10 we have a big production file. So you can see maybe in the average the sulfide reaction in 9.5. Next. This one, the magnesium salt is very similar to as well as PS9 and PS9.5. Next. Yeah, this one, variation of saturation index as a function of PS. Next. Yeah, this here is RT analysis. We can see, yeah, now different, yeah. Okay, next. This one, for our research in PS9, yeah. Next. Next. This one, the FER spectrum white sample that we produce at pH variant and also molar ratio variant. Next. This one, send image, yeah, of profile that was produced at 10 molar ratio 1:1:1, 1:2, and 1:1. So in the left picture, we can look the distribution for the profile. Okay, next. This one for differential weight loss. Yeah. Good. I think it's very simple, yeah. But as in our team to solve the DDR proof. So next. Yeah, this one, weight loss, proof of survival for PS failures. Next. Yeah, conclusion. So our presentation will have concluded at magnesium phosphor ion of 1.5 and PF adjusted at 9.5, a high phosphate recovery efficiency was achieved with a minimal difference for the three magnesium sources. The study demonstrated that in general, the high nitrogen phosphor molar ratio, both pH 9 and 10, makes lead to the significant formation of sulfide. Yeah, the high pH will be the significant formation of sulfide. So the demonstrated ability of sulfide precipitation using the three low-cost magnesium source tested to recover phosphate make it an environmentally sustainable solution for phosphate scarcity. So the last, our conclusion. All magnesium sources for sulfide production comparable with seawater, especially the desalination waste, is an alternative, richer, environmentally friendly and more sustainable magnesium source for sulfide synthesis. Okay, thank you very much for your attention. I'll back to Brother. Thank you.
Thank you, Rob. For the interesting thoughts, we have lost. Now, I will offer one question to this president and the institution. In bahasa Ibu. Is there any question? Are there any questions?
Intinya tuh ya sesungguhnya reaksi ini sangat sederhana sekali. Sambil kita minum kopi, ya di depan meja itu bisa langsung. Saya kira tidak perlu diubah.
If there is no person, it's not okay, and then, for the certificate.
Okay. Thank you very much, Professor Vicky Waibeltani and Professor Edi Penalty for the second plenary session. Now we will present a certificate and souvenir to our estimate conference presenter as the appreciation for their valuable contribution to the conference. To present the certificate, I would like to invite the chairman of the organizing committee, Professor Admanto Herwibowo, to join the stage. To Professor Admanto Herwibowo, please welcome to the stage. Thank you to Professor Vicky Waibeltani for the presentation to this event.
The next agenda is plenary session 3 and 4 that will be delivered by Professor Tetsuya Nozawa and Professor Santiago Gomez. At the end of plenary session, there will be a discussion session. This plenary session will be guided by Professor Fendi Suyanti as the moderator. Please welcome Professor Fendi Suyanti.
Assalamualaikum warahmatullahi wabarakatuh. Good morning. We are in the session 2 of the plenary session. In this session, we will improve our study systems. In there we will swap the first presenter will be Professor Santiago Gomez, and the second presenter is Professor Tetsuya Nozawa. So, start with Professor Santiago Gomez. I will try to give a brief introduction of Professor Santiago. Professor Santiago is a full professor in organic chemistry from University Rejuan Carlos, Spain. He hold a PhD from University Rejuan Carlos, Spain, in 2004, and since 2020, he is a full professor of organic chemistry. His work focused on the design and preparation of metallic drug functionalized nanomaterial with therapeutic activity, and also novel advanced material with photocatalytic application. Today, Professor Santiago will give a talk on theranostic system in biomedicine, integrating imaging and therapy in metal drug functionalized nanostructure. Your time is 2 minutes. Thank you.
Yeah. Thank you, Professor Fendi, for the kind introduction. Thank you for the invitation to be here to give this talk about the its application of nanomaterials. First of all, I would like to show you who we are. We are the group of metal complexes and nanostructured materials. So we are the Comet Nano Group, and we are located at the Universidad de Juan Carlos in the capital of Spain. So today I'm going to talk about therapnosis and in the context of nanomedicine. Nanomedicine is the medical application of nanotechnology. It can go from, for example, medical application of nanomaterials to biological devices or even biosensors. And one of the current problems of nanomedicine is now focused on the understanding of the toxicity, environmental impact, and how it's working in that space. So if you see the incidence of medicine, it's very high. So look at the number of papers that have dramatically increased from 2000. Sorry, it was like less than 5 papers with the nanomedicine. And now in 2023, it's more than 21,000 papers with incidents. And this has allowed the development of a wide variety of nanomedicine's clinical use. From the very first one in 1995, so the Toxin, that is a PET liposome formulation of medicine, to the last one that is Fiagro, this discovery, put it in the market in 2021, which is albumin drug nanoparticles. So these systems, these nanomedicines, have allowed very, very strong research that have gone from the beginning of the discovery of nanoparticles in the 1950s, 1960s, and have allowed the use of a very wide variety of materials, going from polymers to even to liposomes or inorganic nanoparticles, like for example, silica-based nanoparticles. Actually, silica nanoparticles are the objective of our research because they are very easy to prepare, they resist very high resistance. They have been used in a high number of applications, and they can be loaded and functionalized with several molecules, and this is very useful for the design of the biological agents. So the nanoparticles, silicon nanoparticles, if you look at the term nanoparticles or nanomedicines and silica, so starting from 2005, it was the first paper combining these two terms. And now we are producing around 1,000 of papers in the last 5 years per year. So that means that this, let's say, field of also a very high biological importance. So if you check how is the different milestones that silica have been achieved in the development of nanomedicine space with silica. So the first was in 2007, and now a wide variety of patents, clinical trials are starting to be used with silica. But just screen a couple of them that are labeling the silica nanoparticles with ISO 124 or volume 89. So silica nanoparticles lack of the concept of therapnosis. So what is the concept of therapnosis? Therapnosis is a mixture of two words, therapy and diagnosis, and it's referring to a combination of diagnosis and the treatment that may allow continued medical assessment of patients. So the term therapnosis is relatively new because the first paper using this term therapnosis for 2009, and now only around 150 papers per year are being including this term. So therapnosis is just combination of therapy and imaging or diagnosis, and we need an in this context, so there are many challenges for the use of different therapeutic drugs, and many challenges for the use of very different diagnostic agents, and of course, all the diagnostic systems may be interesting for being applied in cancer treatment because they can be using combined multitherapy, and they can be interesting to be applied in chemotherapeutic agents, but also in immunotherapy. So, but they will also suffer from the same problems associated to drug delivery systems, which is going to be the barriers for the delivery in the tumor area. So this must be, we must really choose properly the way in which they will be administered. Also, they will also have the problem of the multi-drug resistance, because multi-drug resistance is usually associated to a very wide variety of things. In this context is where our previous work focused on the design of organotin for agents was important, because we have demonstrated that some organotin agents have, are not substrates of the PDP protein, and they overcome the multi-drug resistance. So they might be really interesting for being incorporated in the system as a therapeutic agents. And then we develop a wide variety of compounds with potential properties to be incorporated into this. And this was our objective. So to prepare a nanotherapeutic system based on silica, nanosilica as the carrier. So as therapeutic agent, the organotin for because they overcome the resistance, and using fluorescent flows, like for example, coumarin 343 or Alex fluor, they emit in the near infrared area as potential nanotherapy system. At the same time, we also wanted to include a targeting agent to try to direct the material to the exact target in the organs. So that will be achieved. So in this context, we know ourselves because we know what we want to prepare. We know our enemy, which is the cancer. So we are prepared for starting the battle. Because as Sun Tzu in the book The Art of War wrote, if you know your enemy and yourself, you need to not fear the result of 100 battles. But if you don't know you or don't know your enemy, you will fail in every battle. So now we have to think about the second part, which is strategy without tactics is the lowest route to victory, and tactics without the strategy is the noise before the victory. We have the tactic using the diagnostic system. We now have designed the strategy. And the strategy was based on preparing drug delivery systems, avoiding complex and expensive stimulus responsive systems, and all these different steps that we are going to give. So, tuning and adjusting the therapeutic agent, improving the selectivity, preparing the diagnostic system, in vitro and in vivo studies, studying the toxicity in animal models, and finally the implementing of drugs. Let's go with the first. What did we do starting from this kind of systems? Organotin is typically for hexanol or derivatives that have a different moiety, which is associated with very high toxic activity, and this alcohol chain that is prepared for an easy anchoring on silicon nanoparticles. And this is what we did. We incorporated these systems in silicon nanoparticles. We observed that they release very low quantity of steam in the biological medium, so they are acting as non-classical drug delivery systems. They do not need to release the cytotoxic agent to become cytotoxic, so we need to have a stimulus for drug delivery, so they will be cytotoxic in the case. And so we observed that they decrease the metastatic properties of cancer cells. They also discovered the motility of the cells, and they promote the B38, the mitogen activated protein kinase pathway, which usually suppresses the cell survival, and this is leading to very high selectivity. The second part was improving the selectivity. How to improve the selectivity? We actually were more focused on triple negative breast cancer because it was so rejected, and these kind of cells, they overexpress the foreign receptors. So what we can do is to incorporate folic acid, for example, in the structure of the systems. And this is what we do. So we incorporated folic acid, we incorporated the organotin agents, and then we studied how is the activity of these systems against triple negative breast cancer. So we observed that higher amounts of folic acid leads to higher cytotoxicity. Also, that the incorporation of folic acid modulates the FOLR1 receptor, and this modulation of the FOLR1 receptor influences the soluble secretion of the receptor tumor cells, and therefore it was inhibited so leading to cancer cells. So we have improved the selectivity. Now we have all, let's say, the tools that we need for the preparation of the system, incorporating an imaging aid. So we did a proof of concept for that. So this was our idea. We have already incorporated the folic acid, the organotin agent, and now we wanted to include also an imaging agent like Coumarin 343 that is emitting around 380 nanometers that can be useful for confocal microscopy, and therefore we incorporated the Coumarin 343 and folic acid at the same time using an amino-fractionalized nanosilica, and in a subsequent step we incorporated here in green the organotin agent. So we have now organotin agent, folic acid, and Coumarin 343. And then we demonstrated that we can see these nanoparticles in vitro test. And we also observe a higher internalization of the nanomaterials when we are adding the folic acid. So at this stage, we were able to have a proof of concept of a therapeutic agent. So now is the possibility to include or to change Coumarin 343 by Alexafluor, which is an agent that is versatile because it emits in the near infrared, and this can be useful in EV. So this led us to go to more in detail this kind of systems in vivo. So we prepare the corresponding nanomaterials, once again with the folic acid, with the target, with the therapeutic agent based on fragment, and also with Alexafluor. CX-47, and we observe so the image localization and also the decrease of the tumor size after treatment with this kind of systems. The good thing is the accumulation of the nanoparticles in the tumor area principally, and also we even increase the cytotoxic activity, we increase the potential applicability by adding a second additional therapeutic agent, in this case, FDA-approved drug like chlorambucil. So with a system based on the incorporation of chlorambucil, organotin agent, folic acid as the targeting agent, and Alexafluor as the image agent, and we did some additional in vitro experiments observing a synergistic effect between chlorambucil and the organotin fragment, and also good cytotoxic activity, good cell migration inhibition, and very high metastatic. And studying the systems in vivo, we also observe the selective accumulation of tumor soil, decrease in tumor volume, and what is even more important, reduction of the blood flow and vascularization after the therapy. If you look at the slide, you can see here, so the control mice, where you see that the decrease of the vascularization is from 100% to 90%, so no decrease. And when using our material, so this vascularization decreases of around 60% from 100 to 40%. So additionally, we studied mice, and then we observed no alteration of the biochemical properties. So now we have a system that is really interesting. We confirm this the case of the vascularization, so this anti-angiogenic properties by using modeling chicken embryos, in which we observe that these systems are able to reduce the number of junctions between the capillaries, the junction between the processes. So therefore, our strategy must conclude with studying the toxicity. So what happens with these systems? Are they toxic or not? So we studied those systems in the tumor-bearing experiment, and we observed that the main accumulation of the tumor is located in the tumor. So after just 48 hours, the highest quantity is only in the feces. So it has been distributed only through the tumor area and not within all the different organs. But this is only happening when using nanosilicon. When you use the organotin compound, the free organotin compound, this is accumulated in the organism. So the nanoparticles are really directing the system to the tumor area and are facilitating also the spread. Okay. So, as I told you before, now we are in the final part. So we need to check. So accumulation is in the different organs, but what happened with the tissue in the different organs? This is damage. It seems not to be damaged because it's not going to be accumulated there, but we still have to analyze the mice. We still have to sacrifice them and check how is the tissue in the different organs to see if there was changes. Fortunately, it came because without images is complicated. But it's not working. This is not working. Can you go a slide further? The next one. Okay, so here, as you can see here, so we have the control mice and the S3 mice, which is treated with the material. So we see very similar damage or very similar, not really damage, but similar morphology of the tissue. And if you go next one, so you will see that in all liver, brain, heart, kidney, lung, and spleen, there were no significant damage using up to 100 milligrams of our system. But if we compare this with the S4 of the seed, S4 is just the organotin compound, only the compound without the nanomaterial. To see that as the accumulation was in the different organs, the organs were also damaged by the accumulation of the tea, but not in the case of the nanomaterials. And in the case of the seed, that is the whole family, this is a compound that we know that is being accumulated everywhere and is damaging all the different. So the good thing is our materials are okay. So we are just close to the end because it's the last part of the strategy, the taking benefit of transport and intervention. If you remember one of the first slides that I showed you, it was the evolution of the different medicines within time. And the last one was Fialco. The technology is including drug nanoparticle and albumin-based nanoparticle, albumin encapsulating some drug. So we had that idea in mind, and what about using albumin as the transport of our nanomaterials? And this is what we did. We prepared the nanomaterials, we did sample modification, we just incorporated the therapeutic agent, incorporated the diagnosis agent, and finally we tried to put the albumin to create a hybrid nanosystem. And this is what we did, and this is what we studied still only in vitro. This is a paper that we have published in statistics, and we observed that the active targeting of albumin is assisting, promoting, and increasing the internalization of the nanoparticles inside the cancer cells. So we were sure of this, and we were sure that they both are going together because we label albumin with one fluorescein isocyanate, and we label our nanoparticles with isocyanate green, and going to do the merging of the images. You can see that they are all together. So these violet spots in the right, they are demonstrating that they're both going together inside the cell. So albumin is a sustained incorporation inside the cell. So this is the main part of our work. We are also developing additional systems based on other metal ring flags like nanoseeds or nanoseeds, also in other different image agents. And we are also changing the strategy by not using silica, but some other nanomaterials, like for example, graphene dots. We are working now in the development of these kind of systems because quantum dots can they emit in a wide range of wavelengths, and as you can see, using different lasers in the total microscope, you can still see the graphene quantum dots, and they can be very useful for the image. So the conclusions of this work is that we have a wide variety of toxic and metastatic organotin compounds that have been incorporated into silica, have led us to prepare therapeutic agents that have been studied in vitro, also and in vivo against triple-negative breast cancer models. Also, we have demonstrated that the recent anti-angiogenic properties systems that they do not alter the biochemical parameters of the mice. They are not toxic. They have provoking damage to the different tissues. And these systems can also be internalized by using proteins such as albumin, and they can be used to formulate other kind of nanoparticles in the future. So I would like to thank all my collaborators, many different scientists from many different parts of the world involved in this part of this project, and also, of course, thank you very much to my group, because this is completely impossible without their work, because they are really the actors of this work. I am here the presenter, but the actors are all these guys like Peter that are really hard workers and developing this kind of materials. Not only those that I presented here, but also some others that we are doing in analysis. And of course, thank you for funding to all these funding sources, the PhD and so on. And thank you very much for doing the event.
We will have a presentation in the end. So we will have the second speaker is Professor Yunis Zawan. Professor Yunis Zawan is a lecturer at the University, Department of Material Science and Engineering. having introduction. His research primarily focused on the field of African with a special interest in the development and characterization of nanoparticles and their application in finance technology. He has contributed significantly to the field through numerous application and research projects. His work includes the synthesis and application of metal nanoparticles such as gold and silver for use in areas like devices and energy technologies. It has been involved in developing advanced material for thermal energy storage and electrocatalysis for energy application. Today, Professor Tetsu will give a talk on oxidized copper nanoparticle for low temperature sintering in power electronics. Like as yours, Professor, you have 30 minutes.
Yes, thank you very much. So thank you very much for inviting me here. This is the first time to Indonesia, and I very much enjoyed several days in Indonesia. So I want to start my presentation. Yeah, my name is Tetsu Nedo from Hokkaido University. So the next week. Yes. So I graduated from Tokyo University and then I moved to Switzerland and France also. Then I come back to Japan and worked at Kyushu University. Southbound. And then moved on to Nagoya University as an associate professor. Nagoya is a city of automobiles that Toyota is located in. And then I go back to Tokyo, and now I'm working in Hokkaido. And I collaborate with some famous university, probably much more famous than my university. And I'm now visiting professor, also honorary professor of Taipei Tech. And next one, please. Can I go to the I'm sorry. This one. Okay. And Sapporo is located in the north of Japan, and as you can see, we have much snow in winter. And in 2035, we have a season from Tokyo to Sapporo. It takes about 4 hours. Now, from Tokyo, no. And there is a big night now also. And Hokkaido University has the biggest campus. And summer is like this, and winter we have much snow, about 2 meters, and the fall is beautiful. Yes, this one. So the north-south is about 3 subway stations, and west-east is about 2 stations. So very big campus. So I'm very happy if you visit us. It's very close to the main station. So you fly to Tokyo and then go to Sapporo, and then just 3 minutes train, you can arrive our campus. So I'm working on nanoparticles. First, I try to make such alloying nanocatalyst, and then I use some nanoparticle arrangement in order to make a very narrow, electroconductive layers as well as energy coming and get out from here. And this is probably bio-related materials. This is photo system 2, and profile is purple. And one photo comes here, one electron generate, and electron go to gold nanoparticles. And this semiconductor understand one electron comes. So this is the smallest one photon sensor. And we also make a special structure nanoparticles. These are used for the laser induced mass. So this work is with Japanese and Hollandese in order to detect illegal drug. And today I would like to talk about the materials for electronics, and we are working to make luminescent metal nanoparticles. Usually metals cannot show any luminescence, but if we make a small nanoparticle, it makes luminescence. So we make gold small nanoparticles, which has a luminescent center. And we also make usually inorganic nanoparticles negatively charged, and we try to make a positively charged nanoparticles. And this is another way we irradiate IR laser to gold nanoparticles. And gold nanoparticles emit X-ray. So the nanoparticles can work as an X-ray generator also. And we also make some nanoparticle thin-wire batteries. And this is, some gold nanoparticle gels for the X-ray markers, especially for breast cancer. Now we try to use this one for the, in Japan, the females cannot select radiation therapy against breast cancer. So we try to use these X-ray markers for the breast cancer in order to increase quality of life for females in Japan. And also I advocate our faculty. My faculty is the faculty of engineering, but we can invite every year 1 or 2 visiting professors between 2 months to 1 year. So if you want to stay in a cooler summer, you can apply 2 months visiting professors. And also we can invite internship students, undergraduate or graduate students, if you can stay in Hokkaido. If you want to ski in Noita, you can apply me. So I will introduce how to do it. Anyway, so let's start my study. So I am also working on nanoparticles as a previous speaker. Previous speaker talks about silica or graphene nanodots for bio applications. But I'm always working on metal or metal oxide nanoparticles. So as you know, metal nanoparticles, especially precious metal nanoparticles, are used for catalysts for a long time. For example, in the car, there is large amount of noble metal catalysts in order to decrease the pollution. But in the field of electronics, we also use nanoparticles for signaling. So recently, Japan becomes much weaker country for semiconductor. 12 years ago, when I was young, semiconductor industry in Japan was very strong, but it goes down dramatically, and we must fight with China, Korea, and Taiwan to make a good semiconductor with low cost. So semiconductor, now it is very complicated. You have many memories on one chip. And in the field of semiconductor, if you take a train, train speed is controlled by the current, but it is not controlled by a resistor. It is controlled by a semiconductor, and that semiconductor works not that semiconductor is not operated at the room temperature. The temperature of operating is much higher than in temperature. Even recently, 150 degrees Celsius or 200 degrees Celsius is the operating temperature for the high power semiconductor. So, but in order to connect the semiconductor to the, how to say, to the feed or to the conductive wires, or connect with a heat sink, we usually use a solder. Solder is alloy of tin. The melting temperature of such solder is very low, between 150 to 200 degrees Celsius. So if the operating temperature of semiconductor increases, we cannot connect the semiconductor tin correctly with solder, tin alone. So we use high melting temperature materials, high melting temperature metals for this purpose. But you know, operating temperature is 150, but if we use silver, melting temperature of silver is 1000 degrees Celsius. But of course, it is always solid at low temperature. So we cannot use the silver as a glue between the heat sink and the tip. If we make a nanoparticle of such high melting temperature metals, the melting temperature decreases with the size. If the silver nanoparticles has 1 or 2 nanometers, melting temperature of such small nanoparticles is about 200 degrees Celsius or less. So we make a small nanoparticle paper and sinter it and connect together. Then we can use such silver as a glue between the tip and heat sink. But as you know, silver is very expensive, enough expensive. So the alternative element is copper. Copper and silver have a similar electroconductivity as well as similar thermal conductivity. But all of you at least, you are well understand that copper can be oxidized very easily in the presence of oxygen, especially in the presence of oxygen or water. So, you know, there is some copper oxide, CO, CO, black part, and CO2, orange part. And there is another oxide, CO4O3. So, copper has many oxide. So we try to use another copper oxide in order to prevent further oxidation of copper nanoparticles. Yeah, that is our value is as small as 100 nanometers. First, we try to connect heat sink and semiconductor tip. We oxidize the surface of copper particles and reduce and the reductive atoms, it means under hydrogen. So then we can see that as low as 150 degrees Celsius. So we can do that if we can use a copper oxide. But we don't use hydrogen because hydrogen can reduce copper But the hydrogen may use another materials in semiconductor chips. So we don't want to use hydrogen. What hydrogen is explosive. So it is well organized. The factory should be well organized when we use hydrogen. So what we should do? Copper is cheaper, okay, but easy to be oxidized. Once oxidized, hydrogen is required. And we try to make a copper nanoparticles from copper oxide. And we collect these particles. This copper particle is covered by gelatin. So gelatin is aggregated with lower pH. So we try to get particles just by decantation. Oops. So we can control the particles very easily. And the organic layer, gelatin layer is like this. This is the PM. So the nickel. Nickel is oxide, but nickel oxide oxidation is stopped with a very thin nickel oxide layer. So in the case of copper, we must do some organic layers, but this is 5 nanometer gauge. So only 1 or 2 nanometer thickness is enough to oxide copper. And then we check the surface very carefully. I'm a material scientist and I'm a microscopist also. So I use almost every week my electron microscope. So this is a copper particle obtained under air and pH 10. I do not explain in detail, but you can see there is a clear boundary. And A side, inner core is metallic, and B side, surface is CO2O. So you can understand the fringes means the distance between the lines. You can understand the metallic. So this is a usual particles. Usual copper particle is oxidized, and the surface is CO2O. And this one, this is the middle one, center one, we corrected under air and pH 8.5 a little bit lower. So gelatin is more strongly. So in a core is metallic, of course, the surface is CO2O, and E area is metallic, F area is CO2O. So we change the pH. Surface, some air surface can be kept as a metallic always. And we obtain the particle under nitrogen. So in a core is metallic, and H, the phase distance at H is 2.2. It does not correspond to metallic copper, nor to C2O. So first we will this paper and submit it, and definitely does not agree this point of view. So we check the X-ray in encyclopedia carefully. We found that this is Cu6Q4O. This is the unique crystal structure, but labeled almost 50 years ago. But just one paper. And after that, I checked 2 or 3 papers described C6Q4O, but just oxidized the surface my particle. And then, you copper as a metallic copper, the crystal is the upper side, center one, and Cu2O, Cu3O4, CO, and C8O, this is blue one.
And Cu64O, this is green. And we combine Cu64O and metal copper, you can see like that. So if I can convert Cu64 to metal copper, copper atoms must be fused, must move. Only eliminate one oxygen molecule, one oxygen atom from 64 copper. So if I can make this Cu64 by ourselves, it must be the main material for semiconductor industry. Nobody made that. So we prepare our particles by using the hexanic acid on the surface. And we take the hexanic very carefully. We can find a very tiny big diamond area. But we can understand this is Cu64. So if we buy copper particles, probably the supplier gives you the hexanic plan. But carefully between 40 and 42 degrees, if there is a small peak, the surface is Cu64. But our pathway is not also that CO2 or CO because there is no peak smaller than 40 degrees. And we prepare the space by using a BB and put our particle on the aluminum and see that. So this is out. So we prepare diamond A, we prepare our base under air. In that case, the surface is re-oxidized to CO2. And then square is further than the air and theta under nitrogen. So that line is not small resistivity, so less conductive. But we put hydrogen, the conductivity becomes higher. And even 150 degrees Celsius is enough to obtain good conductivity. But we need to expand our particle under nitrogen. It means the surface is covered by Cu64O. Green triangle centered under hydrogen, and purple circle is centered under nitrogen. So green and purple is almost same. So Cu64O can be centered even under nitrogen without hydrogen, but it becomes to metal at low temperature. Of course, up to 250 degrees Celsius, small portion of oxygen in nitrogen gas oxidize the particle, but at low temperature, Cu64O turn metal copper without reducing reality. So we made it. So this is SEM surface SEM. The upper side we use hydrogen, underside we do not use hydrogen, but the centering structure, linking structure is almost same. So this is the first case. We can obtain high conductivity without hydrogen, without the reducing condition. Low temperature. So this is the mechanism. So we discovered on the nitrogen, Cu64O is on the surface, and the nitrogen we can obtain a synthetic. But if it is oxidized to this 2O, hydrogen required. So the key point is C64. You can understand now. And you check the X-ray encyclopedia, you can find that. And I am a chemist, so I want to make C64O1 only. And we try to do that. We put I on some ligand and reduce under air with hydrogen N2H4. And then obtain small tiny copper particles. This is a dark field image of copper particles. And the size is about 2 to 5 nanometers. And you can also see the smaller particles. The smaller particles may be some clusters, but we don't have any idea of this detailed structure. But anyway, larger particles, smaller clusters cannot show any, but larger particles, 2 to 5 nanometers show XRD peak, and you can see the broad peaks. And large peak, red lines, it never corresponds to metal cover. So this is not metal cover. Not to CO2, never to CO, not to CO4O3, and corresponding to CO4. Smaller particles, the peak position is corresponding to CO8. So now we can make such copper nanoparticles. This is the first time we can make by ourselves. I should say, we can make C64 nanoparticles as materials. And this is the atomic resolution SPM, scanning image, and the copper. Black dots corresponding to copper. One dot does not corresponding to one atom. So X-ray goes this way. So one dot means several atoms aligned this way. And maybe you can see the white arrow shows a small gray dot between the black dots. And electron loss spectroscopy reveals that the gray dot is corresponding to oxygen. So we don't know how to get every oxygen in this SDA image, but anyway, we can find that copper atoms are regular looking, it is crystal, and very small amount of oxygen is located in one particle. If it is CO8, we must find more CO2, of course, we must find more. And this is the heating XRD. So we have very small conventional X-ray diffraction, and we made by ourselves the heating cell. And we heat up to 80 degrees Celsius and up to 150. And you can see at room temperature, the peak is very corresponding to C64. And we increase the temperature 60, still C64. But 8 degrees, 1 minute, you can see the peak is shifting to metal copper. So it means under nitrogen, without hydrogen, 60 to 80 degrees Celsius, a particle is converted to metallic copper. So there is some crystal structure change at low temperature. Usually, crystal structure change of metals should be much higher. But in our case, CO64, thanks to the very small amount of oxygen in low temperature,
and change the temperature. And then the peak becomes higher and higher with increasing the temperature. It means the crystal grain size becomes larger. And we show the grain size on the left side. As you can see, the particle size is 2 to 5 nanometers, but the grain size, grain means the crystal structure, one single crystal structure in particle. So 70 nanometers is very large compared to 2 nanometers of single. But the temperature is still 150 degrees Celsius. So it means go down smooth, diffuses, very low temperature, even the melting temperature of carbon is more than 1,000 degrees Celsius. So sintering means a carbon particle, condensed particle together, and heat will make one metal plate. We can do it at low temperature at 150. So this is a section of the image of particle. Just 1 minute, you can see one particle size becomes 20 nanometers. The single particle will 2 to 5 nanometers. So just 1 minute is enough to make a big particle. So sintering occurs. And longer time, for example, 2 hours, you can see the bigger particle here. So atom diffusion comes as low as 1 degrees Celsius. So now we use these particles for semiconductor industry, not only as a glue between the team and I finished 1 minute, okay? And kissing, as well as we use them as conductive lines in 3-dimensional pattern. So thank you very much for your kind attention.
Because we will have a question session. Session, we have similar topics. Session, one is in implementation, in medical application, and one is in telecommunication. This event, if you have any question, please mention your name and your institution.
University. My question is to Professor Santiago. In Indonesia, the big newspaper is called Yes. Because the very newspaper on the side. How possibility your thoughts to make the cancer system in the brain in order to reduce the agenda Parkinson and so on. Because we know my professor died because Jacob. Thank you very much.
Yeah. Thank you for the question. Actually, it's a very interesting question. And it's not easy because one of the slides that I showed you, I said to you, one of the problems with systems is the administration and to reach the place. For Alzheimer or for Parkinson or even on neurodegenerative diseases, maybe you need another platform because you need to cross the blood-brain barrier. You need to play this strategy probably the career will not be the same, but all the lessons, all the things that we are learning with this kind of systems in cancer could be translated, changing the platform and changing the design to neurodegenerative disease. Indeed, we have already working on a project that is focused on lateral sclerosis and lateral sclerosis, which is also neurodegenerative disease or a brain disease. And these kind of systems are starting to be applied in Alzheimer's, dementia, Parkinson's, etc. So they can be useful, but still a lot of things to do.
One more question.
We are certainly explaining that.
Session is so this was for to hear your session, expand our project, especially in science. Probably we can also regarding material because application is so wide. Okay, thank you very much for your attention. And I give mic to Nancy. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Professor Francis, for your guidance to the plenary session. Now we would like to acknowledge and appreciate the contributions of our esteemed presenters to present the certificates and souvenir. I would like to invite the Vice Rector it's Professor Triana Kusumaningsih to join us on the stage. As I call your name, please come forward. Professor Triana Kusumaningsih. As I call your name, please come forward. Professor Tetsuya Nezawa and Professor Santiago Gomez Ruiz to receive your certificate and souvenir. Congratulations to all of our presenters, and thank you once again for your outstanding presentations and contributions to the conference. Let's give them all a big round of applause.
Ladies and gentlemen, before we go to our next agenda, the grand opening, we are now in door prize sessions. So there is a little door prize sessions for these sessions, like look at the question and please raise your hand if you know the answers, because there is a special door prize for all of you. Okay. My partner, Batu, will give the questions, and please raise your hand if you know the answer, because there is a special door prize if you know answer to answer. Please give the questions.
Okay, the first question is, who is the newly elected rector of ONS?
Please raise hand if you know the rector of Universitas 11 Maret. Do you know the name of the rector of Universitas 11 Maret? This answer? You put Google also for the answer? Oh, yes. We already have the Could you tell me your name and your institution first?
My name is Andy Thomas. I'm from the Universitas Maret. And the answer is Dr. MSc.
Okay, correct, everyone. Okay, congratulations for your name is Anida. Congratulations, Anida, for your door prize. You could you could take it in front of the stand of the emblem in front of this main hall. Congratulations, Anida. With your applause. Please stay to our next door prizes because there is still door prizes here. Excellencies, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, Namo Buddhaya, Salam Kebajikan. It is such a pleasure for me to inform you that among us here we have to the Honorable Professor Dr. Vidya Rahmawati, and the Vice Rector of Academic Affairs and Research, Universitas 11. To the Honorable Associate Professor Suci Handayani, as the Dean of Faculty of Mathematics and Natural Sciences, Universitas 11. And also our keynote speakers, to the Honorable Professor Claudio Tiribelli from Italian Liver Foundation, Trieste, Italy. Professor Edi Heraldi from Universitas 11 Maret, Indonesia. Professor Tetsu Yonizawa from Hokkaido University, Japan. Professor Santiago Gomisui from Universitas Juan Carlos, Spain. Associate Professor Dr. Muhammad Khalizan Sabullah from Universitas Malaysia South. Associate Professor Oki Gureda from Pertamina Company, Indonesia. And to the Honorable, all of our invited speakers and presenters, and to our beloved audience, welcome to the 19th Joint Conference on Chemistry 2024 in Surakarta, Indonesia. Please give applause to the Joint Conference on Chemistry is an annual conference organized by the Chemistry Department from 7 universities in Central Java. With consortium, Universitas Diponegoro, Universitas Negeri Tengah, Universitas Jenderal Sudirman, Universitas Kristen Satya Wacana, Universitas Muhammadiyah Semarang,
Sekolah Negeri Wonosobo and Universitas Sunda. The Joint Conference on Chemistry has involved in a major global event focused on chemistry, material science, material physics, material analysis, and material characterization. This seminar accommodates the information of research results from chemical lecturers and researchers from over the world. This year, we have the main theme with the title, Evolving Sustainability Harnessing Chemistry to Shape an Eco-Friendly World Across All Aspects of Life. To begin this conference, please let us introduce ourselves. My name is Deviana Saputi, and my partner.
My name is Nadia Malawati.
Dr. Shakiran Aurelia as your Master of Ceremony for this conference. Please follow me to the several sequences of our agenda for today. First, the plenary session that will be guided by Professor Witri what we will study. Second, the plenary session that will be guided by Professor Frankie. Third, is singing the national anthem, Indonesia Raya. Fourth, is the opening ceremony and dance performance. Fifth, is the opening remarks by the organizing committee. Sixth, is the opening remarks by Vice Rector of Universitas Sebelas. Seventh is lunch break and praying. Then there will be a plenary session that will be guided by Professor Frankie Suyanti. Then, presentation, and the last one is closing ceremony.
To continue our agenda, let us continue that we will going to deliver our national anthem, Indonesia Raya. To all the participants, please stand. Very much to the honorable participants, please sit down.
The honorable attendees, on behalf of the organizing committee, I warmly welcome to the opening ceremony of Joint Conference on Chemistry 2024. It is a truly honor to have all of you here today for the insightful and engaging event. And to open this prestigious conference, we are pleased to present to you a special dance performance that beautifully merged two of Indonesian rich cultural heritage. Now, we will witness the Tari Sunda Kreasi Bali, a fusion of Sundanese and Balinese traditional dance. Please welcome Tari Sunda Kreasi.
Thank you very much. Let's give them a big round of applause. Distinguished guests, respected speakers, participants, and colleagues, welcome to the opening ceremony of the Joint Conference on Chemistry, hosted by Universitas 11. We are honored to have all of you join us for this significant academic gathering where experts and scholars come together to discuss and explore the latest advancement in field of chemistry. I would like to invite the chairman of the organizing committee, Professor Armanto Heruwibowo, to deliver his opening remarks. Please join me in welcoming Professor Armanto to the stage.
Mr. Small, I can I'm here just to debate. Respected rector of National University and also vice rector of National University and the dean of Mathematics and Natural Sciences, distinguished guests, distinguished professor, president colleagues, Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, Almighty Allah Subhanahu wa Ta'ala. Thank you very much for this opportunity of the DCC International Conference that is held today from our university. On the behalf of the President Committee of Strasbourg University, I appreciate all of you for cooperation with this scientific conferences, which is normally held by such small consortium. My pleasure to communicate the ideas supported from one of chemistry, education, technology, I expect that this conference will impact in any society, not only in the region, but in the wider society idea of application are coming from this conference. I expect that our collaboration and intention generate even better outcomes in the near future. In this conference, some architects think that we can and expected to share the new education together. I hope this conference deliver the quality of knowledge.
Thank you very much, Professor Heru, for your insightful words and for leading the efforts behind this important event.
Going to the next agenda, it is my great honor to invite the Vice Rector of Academic Affairs and Research of Universitas 11, Professor Dr. Fitri Rahmawati, to deliver opening remarks and official opening comments. Please welcome Professor Dr. Fitri Rahmawati to the stage.
Assalamualaikum warahmatullahi wabarakatuh.
the Honorable Dean of Faculty of Mathematics and Human Sciences, Universitas Maret, the Honorable Chief of History Department or Chief of History Department of Universitas Maret, and all of the council members of Universitas Diponegoro, Universitas Negeri Semarang, Universitas Jenderal Sudirman, Universitas Kristen Satya Wacana, Universitas Muhammadiyah Semarang, and Universitas Islam Negeri Zone. And the Honorable, all of the keynote speakers, Professor Gladio Tirigeli from Harian River Foundation, GST Study, Professor Tetsu Yorizawa, Hokkaido University, Professor Santiago Gomez Ruiz from Universidad Rebuan Carlos, Spain. Maybe this is your sixth time come to UNS, 6 or 7. And to Associate Professor Muhammad Khalizan Sabullah from Universitas Malaysia Sabah. And also Associate Professor Kim Raza from Indonesia. First, praise to Allah Subhanahu wa Ta'ala because today I am able to give an evening with words and in good condition. And it is a great pleasure to welcome you all to this 19th Trade Conference of History. This year, Trade Conference is Chem and Chemistry. So, Trade Conference on Chemistry for 5 days. Empowering sustainability, harnessing chemistry to shape an eco-friendly world across all aspects of life. Sustainability has become a keyword to guide our way forward. And we believe that chemistry plays a significant role in the transition to sustainable practices. Influencing every aspect of modern life, from renewable energy, its reduction, and cost efficiency to green manufacturing and eco-friendly. As the theme of this conference, we understand that empowering sustainability is a collective mission for the young industrial practices and also we all have goals to support a more eco-friendly and sustainable future. This conference is an opportunity for us to share insights, discuss innovation, and engage in interdisciplinary collaboration that will shape a better future. It is my sincere hope that through your collective expertise and dedication, you will to build image, providing solution to the environmental challenge that we face recently. I also encourage you all to take this opportunity to build meaningful connection in research and education, especially in chemistry education, and building a strong collaboration that will empower the global movement toward sustainability. I extend my deepest gratitude to the organizing committee, to the sponsor and partner for their hard work in making this conference possible. Finally, I urge all of you to actively engage with the session, the discussion, the thinking, and the opportunities today. There is a chance for us to ignite ideas, inspire each other, and strengthen our resolve to use chemistry as a powerful tool to shape a more sustainable and Bismillahirrahmanirrahim. I officially open the 19th Joint Conference on Chemistry 2024. Thank you very much for your kind attention. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Fitria Ramadi, for the opening remarks. As a symbol of the official opening of this conference, we are pleased to invite Professor Fitria Ramadi and Professor Ananto Heru to officially open this conference by meeting the law as the part of the official opening ceremony. The World Sounding Conference is now officially underway. Thank you very much, Professor Fitria and Professor Heru, for officially opening this conference. To Professor Fitria and Professor Heru, please stay to the stage because now we will have a photo session. To all the participants, we are pleased to invite to the honorable our keynote speakers and to all of our participants to come to the stage for having photo sessions. Please everyone come to the stage because we will have the photo sessions. Bapak dan Ibu sekalian, saat ini kita akan mengadakan sesi foto bersama. Kami persilakan kepada Bapak dan Ibu yang masih berada di luar ruangan untuk dapat maju ke depan stage agar kita dapat mengabadikan momen bersama di Surakarta ini. Monggo Bapak Ibu sekalian, kami persilakan untuk dapat melakukan foto bersama. Kepada semua hadirin diharapkan untuk dapat maju ke depan untuk melakukan foto bersama. Untuk yang bagi yang masih ada di luar ruangan, kami persilakan untuk memasuki ruangan. Karena momen foto bersama ini akan menjadi kenangan bahwa hari ini tanggal 12 September 2024 telah terselenggara Joint Conference on Chemistry di Surakarta, Indonesia. Sudah siap Bapak dan Ibu semuanya? Mungkin saya bantu gitu ya. Kurang rapat nggak Mas? Oh iya, sudah kurang rapat. Oh iya Bapak dan Ibu sekalian, to all the participants, please. Bapak dan Ibu yang sebelah sini mungkin bisa maju juga ke depan kalau mau. Ya, dan merapat. Oh, iya. Sudah Mas, aman Mas? Oke. Sudah terlihat semua ya Mas? Baik, saya hitung 1, 2, 3. Satu kali lagi, 1, 2, 3.
Ketiganya mungkin ya, ada ciri khas PNS. Ya, ciri khas PNS biasanya OC, C for chemistry, oke. This we will symbol the C for the chemistry. 1, 2, 3. Ada simbol lain Bapak yang mau? Oh sudah, oh semangat yang dulu. Kita satu kali lagi ya Bapak. Dan itu kita empower sustainability. Oke, semangat. Satu kali lagi. 1, 2, 3. Okay, thank you everyone. Thank you to all participants, all guests.
Sholat dulu kan?
Okay. Thank you for all the participants. Now, before we continue to the oral presentation, we will have a lunch break. We will continue the next agenda in 12:45. So please enjoy your meal and thank you very much. Attention please, ladies and gentlemen, the quick announcement for your convenience. For those who wish to pray, the musola or prayer room is located on the fourth floor. Please feel free to use the toilet facility at any time. And I'm also informed that lunch is already and served on the second floor. So please make your way to the dining area for your convenience and enjoy your meal. Hadirin yang berbahagia, diinformasikan bagi yang akan melaksanakan ibadah sholat zuhur dapat menggunakan fasilitas musola yang pada lantai 4. Dan diinformasikan juga kepada hadirin bahwa hidangan makan siang telah disediakan pada lantai 2 UNESCOME ini. Hadirin yang terhormat, dipersilakan untuk menikmati hidangan yang telah disediakan. Attention please to the Honorable Vice Rector, Dian, and the official representation of Universitas Glasgow and all the keynote speakers. We inform you that the lunch break will be held in the UNS Tower restaurant in the 9th floor. Once again, the Honorable Vice Rector, Dian, and the official representation of Universitas Glasgow and all the keynote speakers. The lunch break will be held in UNS Tower restaurant on 9th floor. Kepada hadirin yang terhormat, Wakil Rektor, Dekan, dan tamu undangan serta pembicara federation diberitahukan bahwa istirahat makan siang akan dilaksanakan di restoran UNS Tower pada lantai 9. Hadirin yang terhormat, diharapkan untuk kembali di ruang ini pada pukul 12.45 sampai. Terima kasih.
be the presence of experiment in river and so to be used with a other type of method for